Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, here we go. Let's get started on chapter 10. The first lesson for this unit is cube roots, and this is going to lay a foundation for our understanding of what we're doing when we are finding volume of solid figures and how we can go back and forth between finding volume if we know side lengths and how we find side lengths if we know the volume. So just to get us started, we're going to start with a cube, but eventually we're going to move into other prisms as well as pyramids and cylinders, cones, and spheres. All solid figures, all with their own unique formula, but we're going to learn that there are some basic formulas that apply to many of these different shapes. So first of all, here's a cube. Cube's a three-dimensional solid figure. It has 6 faces, 8 vertices. And remember, vertex is like a corner, so 1, 2, 3, 4, 5, 6, 7, and there's an 8th one that you can't see tucked behind there. And it's got 12 edges. So an edge would be where 2 faces meet. So here's one face, here's another face, there's the edge that separates them. So 1, 2, 3, 4, 5, 6, 7. There's an 8th one running down the back you can't see. Then 9, 10, and then an 11th and a 12th edge. So all cubes share these attributes. And different prisms, different pyramids will have different numbers of faces, vertices, and edges. Probably not something you have to worry about memorizing. Just understand, kind of the basics of what makes a solid figure a solid figure. It takes up space. And so the measurement that we're going to be using for how much space it takes up is volume. Now, a perfect cube is produced by multiplying a number repeatedly 3 times. That's going to be something that we're going to get into in this lesson. Knowing that the cube has all edges are all the exact same length, the same measure, and all of the faces are going to have all the exact same measures, the number of square units, the area. That's one thing that makes a cube unique. All right, so you have previously calculated the volumes and surface areas of cubes and more generally prisms using the lengths of the sides. But what if you wanted to reverse this process? In this lesson, you will learn how to determine the length of the side of a cube when you already know its volume. You will learn about a new operation, which is similar to the square root operation that will help you do this. Okay. So problem number 1, here we have a picture of a cube that has a side length of 3 feet. And since it's a cube, we don't have to label all the side lengths. We know this is 3, this is 3, this is 3. Every single one of those edges is 3 feet. So it's 3 feet wide, 3 feet tall, and 3 feet deep, if you want to think of it in those terms. So this question is just getting you to wrap your brain around what a cube is and what surface area is and what volume is. So using the cube at the right as a model, work with your team. You don't have your team available to you, but you can at least think about it. Create 2 situations that would require to know the surface area of a cube and another 2 situations where you'd need to know the volume. This is typically where students raise their hand after they've had a conversation in their table groups, and we make a list of all the different situations where you'd need to know surface area for a cube or any prism for that matter, and then the volume. So if you want to pause and see if you can think about some different situations, then unpause when you're ready to come back. I'll give you a brief moment here to do the pausing and unpausing, and I'll say, okay, you've just come up with a big list, and let's see if any of my entries are also on your list. And so I said, you're going to wrap a present. That's kind of the idea of surface area, right? Surface area is the total number of square units that cover the entire cube. So we find the area of one side, and then the area of another side, and then the area of a third side. And before you know it, you've got all 6 sides with their areas. The surface area is the total number of square units that cover the entire cube. If you were to paint the exterior, you might need to know how much area you need. Those were two that I came up with. Now for volume. When would you need to know the volume of any kind of a solid figure, including a cube? Well, if you were going to fill it with packing material, you'd need to know how much volume your cube has, so you know how much packing material you would need. And if you were trying to figure out how much space this box would take up, like, you know, you're going to put it on shelves or fill a room with these boxes, you'd want to know how much space is taken up by each one of these cubes. So that's another situation where volume would come into play. All right, so let's start with surface area of a cube. So how do you find the surface area? Well, first things first, we know that the cube is 3 feet by 3 feet. And what is this, 3 feet deep? So if I were to actually create these grids on here, right, break that up into 3 equal parts and then do the same thing vertically, you can see that every single face on this cube is going to have 3 by 3 faces, which are 9 square feet. And all cubes, since they have 6 sides, it's going to be 6 times 9 square feet, which is 54 square feet, is going to be the total area, surface area of all 6 sides on this particular shape. Now, how about the volume? What does that mean to find the volume? I'm actually going to just do those like this, just to kind of give you an idea. Remember, when you're trying to find the volume, it's how many total cubes. Actually, hold on for a second. Let me do this. Pardon me. Go ahead and pause if you want to. Actually, I'll pause it so that I don't have to waste any more of this time. Okay, so if we turn this into like a Rubik's Cube, pardon my not having all those lines meet up perfectly. My OCD, sorry, I'm not gonna do it. Okay, so how many total cubic units fit into this entire cube? So you got 1, 2, 3, 4, 5, 6, 7, 8, 9 on this front face, right? And you've got 1, 2, 3 different layers of this, whether you start at the base and work your way up, or you start on the front and you work your way to the side. 9 plus 9 plus 9 is how much? Well, the base area is 9 square feet, and since you've got 3 layers, that's a total of, stop it. Why you do that? Get out of there. Go. Okay. Then this shows a volume of 27 cubic feet. Okay. So once again, surface area is finding the area of every face on your solid figure and then adding all those areas together. Volume is finding up the total number of cubes that would fill up that space. And I'm going to refresh your memories. Those of you that were not here in 7th grade did not see this, but we had one of the last lessons of the school year last year was how to find the volume of a prism. And it was all set in the context of this fantastic dessert for, I believe, someone named Laverne, and it was an L-shaped kind of a cakey chocolate mousse dessert. And so what we did was we found the area of the pan that this was going to be presented in. And so this was kind of a complex shape, but we break it down into its parts. This is a 12 by 22 rectangle supposedly there. And even though I don't agree that that's 22 and that's 12, but let's just go with it. And then this was 14 by 24. And remember, this would be 14 because the total is 36. And if that's 22, this has to be 14 since 14 plus 22 is 36. So this ends up being 336. That was 264. Add them together. That means the base area of this dessert is 600 square centimeters. So if I just took that very first centimeter, the cookie crust, that alone would end up being 600 cubic centimeters because it would be 600 square centimeters on the bottom plus the height would add that that kind of a dimension, depth dimension, which would make it 600 cubes. And then how many of those 600 cubes, how many layers can we create out of this? Well, if that's 1, that's 7, that's 1.5, then that's a total of 9.5 layers with each layer being 600 cubic centimeters. So I just had us, you probably remember this, maybe you don't, where you take 600 times 9.5. That meant that there'd be a total of 5,700 cubic centimeters that would take up all of this dessert. Now, I believe last year we figured out how many cubic centimeters were just the chocolate mousse, which would be 7 times 600, which is 4,200 cubic centimeters. How much would be in the whipped cream at the top? 1.5 times 600 is 900, so that would be 900 cubic centimeters, and so on and so forth. So that's the basic idea of what we're doing here. If you take what is the area of the base, in this case it was 9 square feet, and then how many layers do you have there? A total of 3 layers. So this is 9 cubic feet, 18 cubic feet, a total of 27 cubic feet when you take all of those layers, which is what I did there. Okay, so that's the basics for finding the volume of any prism. So go ahead and do that now. Now this one, it says a different cube has a side length of 5. Write 2 expressions that would represent how to find the volume of the cube. Okay, so this formula that I have in red right here, volume equals side length cubed, only works for cubes. It does not work for any other prism. It definitely would not work in this particular situation. It's only going to work for cubes, but it does work for cubes. So if you wanted to just say 5 is the side length, and you cube that, what is 5 cubed? It is 125 cubic feet. Okay, if you wanted to use the base area times the height method that we used with the cake, which can be used on any prism, it does not matter what the shape of the prism is. You just need to know how to find the area of the base. In this case, the base is 25 by 25 feet. So we're going to take 25 square feet for the base, and then this height of 5 feet represents all the layers. So if there's 25 cubes in this layer, then the next layer would be 50, then 75, then 100, then 125, ends up being the total volume of this cube. All right. Oh, did I mean to do it this way? I guess I'll just show it to you. I didn't cover it up in time. So now we're going to reverse the process. If you know the volume of how long a side is, oh wait, if you know the volume, how long is the side? I underlined it, so I would stress that, and there I screwed it up. So how long is each side? And this is only applying to cubes, though. Just keep that in mind. Given the volumes of different cubes below, work with your team to find the length of each side length of the cube. So if your cube has a total of 8 cubic units, that means that you repeatedly multiplied 2 times 2 times 2 give you 8. So the sides of that cube must be 2 units. Here it's 125. That basically matches what we had over here, correct? So you'd have a total of 5 times 5 times 5. Those are the dimensions. That's the only way you can get 125, multiplying the same number repeatedly 3 times, which means that each side length of this cube must be 5 meters. And then you got a cube that's 1,000 cubic feet. Well, 1,000 is 10 times 10 times 10. So that means that each side of that would have to be 10 feet. And now we get to one that's a little bit trickier. What number do you multiply repeatedly to give you 40 for an answer? You know, if I were to come over here and say, all right, let's try this. Let's try 2 times 2 times 2. We saw that that was 8. 3 times 3 times 3, that was 27. 4 times 4 times 4 is, what is that? 16 times 4, I believe, is 64, which means that the side length for this particular cube that has a volume of 40 cubic inches has to be between 3 and 4. Good luck guessing on what that might be. It's a little bit tricky, a little bit harder than estimating square roots like we did in at the beginning of chapter 9. So this is where we introduce scientific calculators. This is going to help tremendously. The problem is not every scientific calculator I have found has this function for cube roots. If we go to my calculator here, no, that's not it. Stop it. Okay. We go to my calculator. Remember how the standard calculator had your square root function and then your button for squaring? If I go to the scientific calculator and I look anywhere in here, I see a button for cubing, but I don't have a shift button or any way to turn that into a cube root. So what do? This Casio, which is a calculator that I used to have for many, many years in college and after, has a shift button. And many of you might see that shift button on your scientific calculator, and you see this writing that's on the button itself, which is the primary function. But if you want to go to the secondary function, you hit the shift button and then you press that button. And it's kind of hard to see there. That there says, I believe it looks like this, where it was like square root, or not the square root, but some root, x root of whatever y is your number. Okay, so we need to do this. We need to find the cube root of 40. And so I even went on to like a scientific calculator for Google, and I couldn't see the cube root function on there. So I found this one instead. You're going to come up for me? And I just did a Google search, and I just kept looking at the different online computer functions that were available, and I found this one, and there it is. That's the button you want to use right there. So how does this work? Well, play around with it a little bit. I'm going to take and hit that button, and it's ready for me to put in a number. So I'm going to say, what is the cube root of 40? See how it's inside the parentheses? There's my answer. It's between 3 and 4, just like I predicted. And it's about, it would round to 3.4. Let's just check to make sure that this works entirely. Let's clear that. Let's take the cube root of 8, and that was 2. That's what we said before. What was the cube root of 125? Oops, what is going on there? The cube root of 125, was that 5? Yes, it is. And what was the cube root of 1,000? Cube root of 1,000, I bet the answer is going to be 10. And there it is. Okay, so just search it, or you could type in this address right there, save it for if you don't have a calculator that works, use this one. It'll be just fine for finding cube roots. All right, where were we? So I guess our answer, what did we say? That it was about 3.4. All right, so if s equals the length of a side of a cube, then s squared, or s to the third power, or s cubed, represents the volume of the cube. If the volume of a cube is 64 cubic units, write an equation stating the volume. Wait, what is that? If the volume of the cube is, write an equation using s stating the volume is 64 cubic units. What did I write in here? Oh, there it is. All right, so the side length of that cube, side length must be the cube root of 64. And what number do you repeatedly multiply to give you 64 for an answer? I think we said it over here, right? 4 times 4 times 4 is 64. So any cube that has a volume of 64 cubic units must have a side length of 4 units. Okay. All right. So in chapter 9, you solve problems with squares, such as x squared was equal to 16 by using the square root operation symbol. This symbol, remember, is called a radical. The number on the inside, like in the previous example, the 64, that is what we call the radicand. And the number out here, so there's no number there. If there's no number written like here, then we're going to default to the square root. But this number that goes right there is the root. And in this case, we're working with third roots. Okay, so 3 vocabulary terms: the radical expression, not just a square root symbol anymore, it's a radical expression with a radicand is what you're trying to find the root of, and which root we're talking about goes in the upper left-hand corner. So find the cube root key on your calculator. Different calculators perform it differently, but we've already done this. If x to the third power is equal to 64, then we're going to take the cube root. Remember, we do the same thing to both sides of the equation. The cube root of x cubed is x, since x times x times x is x cubed. The cube root of 64 is 4, since 4 times 4 times 4 is equal to 64. So we would say that x is equal to the cube root of 64, therefore x has to be equal to 4 units. Now here's something that's kind of interesting. No. I'm not ready for it yet. Okay, so if you have already done so, use this key to check your answers. Yeah, we already did it. Let's move on. All right, now just like with perfect squares and square roots, cube roots or of perfect cubes are integers. So 0 is a perfect cube because 0 times 0 times 0 is 0. 1 is a perfect cube because 1 times 1 times 1 is 1. 8 is a perfect cube since 2 times 2 times 2 is 8. 27 is a perfect cube. 64 is a perfect cube. 125 is a perfect cube. 216 is a perfect cube. You can keep going on and on and on. So if we're going to approximate cube roots, we use the same strategy that we used with approximating square roots with the irrational numbers. It's just a little bit trickier. So what I would like for you to do is just try and guess. If you don't get it perfect, that's totally fine. We can check this with our cube root calculator to see exactly what the cube root of 100 is and exactly what the cube root of 10 is. But create a number line just like we did with square roots. With these are your perfect cubes. You know, cube root of 8 is 2, cube root of 27 is 3, and so on and so forth. And see if we can identify where approximately these numbers would go. So go ahead and pause it. I'll pause for a second. Okay, did you find a cube root calculator and check your approximation, your estimation? It's always a good idea to do that. So the cube root of 10 got to be more than 2 since the cube root of 8 is 2. So I'm guessing this is going to be like about 10 point. Wait, what? No, that is wrong. It can't be more than 3. I think I meant to say 2.1. Let's change that. 2.1. That's got to be more like 2.1, somewhere around here. Okay. The cube root of 100 has to be somewhere in here, right? What's the halfway point? Somewhere in close to 90, maybe. So I'm going to say this is probably going to be about 4.6 or 4.7. Cube root of 52 has got to be a little bit less than 4, so maybe 3.7 or 3.8, somewhere in there. And then the opposite of the cube root of 150 has to be somewhere around negative 5.2, 5.3, 5.4, somewhere in that vicinity. Okay, so you can estimate these, but it's harder than estimating with square roots. So use your calculator. Hopefully you have a calculator available to you, or the computers online scientific calculators can help you with the process. All right, so one last thing for me to talk to you about that is not in this lesson. Remember, this radical sign applies to all roots, not just square roots, not just cube roots. You could have 4th roots, 5th roots, 6th roots, any number of roots, and y is always going to be your radicand. So just remember, when you're finding the square root of numbers, you often will not see that number 2. That's the default. It's a ninja 2 up there. So you just know what number do you multiply times itself to give you 64. And so 8 times 8 is 64, so the square root of 64 is 8. This is a cube root. So what number do you repeatedly multiply to give you 27? 3 times 3 times 3 is 27, so the cube root of 27 is 3. And this is a 4th root. So what number do you repeatedly multiply to give you 16 if you repeatedly are multiplying it 4 times? Since 2 times 2 times 2 times 2 is 16, then the 4th root of 16 is 2. Okay, so please copy down these 3 problems. Take a couple minutes, figure out what you think is the answer, and then come back once you've got those answers. All right, so what do you think is the square root of 16? We know the square root of 16. We know that's equal to 4, right? Since 4 times 4 is 16. What number do you repeatedly multiply together to give you 343 as an answer? Well, here, if we look at this number line, the cube root of 216 was 6. So I wonder if that ends up being 7 times 7 times 7. 7 times 7 is 49, and it's 49 times 7. What is that? 63. Carry the 6. 28 and 6 makes 343. That is it. So this has to be 7. And what do we repeatedly multiply 4 times to give us 81? Well, let's see. 2 times 2 times 2 times 2 is 16. Let's try 3 times 3, which is 9, times 3 times 3 again. So 9 times 9 is 81. So 3 to the 4th power ends up being 81, which means the cube root of 81 is 3. Okay, so good luck on your homework. This is all just laying a foundation for the work that we're going to be doing. You're going to find yourselves in situations where you know the volume of a prism, but you've got to figure out side lengths now. So figuring out those side lengths is going to require you to have an understanding of how to find cube roots. All right, good luck with your homework. And I think we're going to do a check for understanding tomorrow. I'm spacing things out now, so we're going to do a couple lessons per week along with assessments and check for understandings and homework. So no new lesson tomorrow, just to check for understanding tomorrow, and then we'll move on to the next lesson on Wednesday. All right, take care.
Hey, feeling good, like I